Good day, everyone, and welcome to Statistics and Probability for Week 7. For this week, the first module is all about illustrating the central limit theorem, and these are the following objectives. First, illustrate the central limit theorem. Second, define the sampling distribution of the sample mean using the central limit theorem and create a histogram of the sampling distribution of the sample mean. So for our first learning task, okay, you are given some questions that will help you to understand this week's discussion. So with the first question, if the mean of the sampling distribution of the mean is 6.5, which of the following statements best describe the population mean? Okay. So basically, when we say that the sample mean is 6.5, it means that the population mean is also equal to 6.5 since yeah, the population mean in this case is equal to the sample mean. Question number 2, what does the central limit theorem state? Okay, so this is just an overview of what we will have for this week. So these are the options. So basically, when we say central limit theorem, when the sample size is large, meaning 30 and above, then you need to use this central limit theorem. Question number 3. Okay. So it states that the mean of the sampling distribution of the sample mean is close to the population means if the sample size is large. Okay, so I will discuss it further. For the fourth question, supply the missing word. So basically, our answer will be, since the center of our discussion is about central limit theorem. For the last question, okay, so obviously, as is stated in the first question, sample mean given, population mean, then it will be the same. In this case, the population mean is given, therefore, the sample mean is exactly equal to 12.8. So for your learning task number 2, okay, which is not recorded, actually, you can make use of this for you to review or to recall, okay? But later on with the next slide, I will show you how to get that, okay? So this is the solution. Okay, we have 2 activities. Okay, you have there coming from the given samples, the 1, 2, 3, 4, 5, 6. So the population size is 6. Okay, then you have there the next column. So obviously to get the population mean, just add this and then divide it by 6. Therefore, the population mean is equal to 3.5. And for our population variance, we have 2.92. Get the square root of this to get the population standard deviation. So we have 1.71. So if you know already these values, you can do the next columns. And then we're able to get the histogram na. So this is the histogram of that problem. Okay, well, on the activity number 2, so there are a lot of observations given. Then from the population or the x given 6, then we need to use the combination formula, if you can still remember that with last week's discussion. So we were able to get 36 observations, and these are the 36 observations. Okay, so it's 6 taken 2. Okay, the formula. Okay, then we tried to list down all the samples, then get the sample mean of each and then the column. So to continue solving for the sample mean, sample variance, and sample standard deviation, we have the following values. Okay. Now, this is the histogram of this. So coming from what we have computed, we tried to list down all the sample means. So these are the sample means and then the frequency of each sample mean, and then tried to get the probability. So illustrating the probabilities and the means, okay, using a histogram, then we have this one, okay? So as you can see with the histogram, okay, we can trace or we can say that it is normal. So, di ba, when we say normal, the shape must be a bell shape. So obviously, it's a bell shape. Therefore, it's a normal distribution. Okay? So to continue, what's the relation of those activities with today's discussion? So I want to give you important points in today's discussion that the number one, that the population mean is always equal to the sample mean. Okay? The population variance is equal to the variance of the sampling distribution divided by n, and the population variance is equal to the standard deviation of the sampling distribution divided by the square root of n. Okay. And that from the histogram, you can see with the population, it's just a straight one. And for the sample histogram, okay, it's a normal distribution. Okay. It's a bell shape. Okay. So obviously, with our activity, it is very evident that the central limit theorem is applicable, and that we can use this is in approximating the sample distribution to be normally distributed. So meaning, the central limit theorem is very important that in cases that a distribution is not normal, by the use of the CLT or the central limit theorem, we will be able to make it a normal distribution. Okay? So what does this state? So if random samples of size n are drawn from a population, then as n becomes larger, the sampling distribution of the mean approaches the normal distribution, regardless of the shape of the population distribution. So meaning from the population, if you can see that it is not normally distributed, then we can get samples from it, and then by the use of the CLT, okay, whatever is the number of your sample size, and considering that as the sample size increases, then the sampling distribution of the mean will approach the normal distribution. Okay? So this CLT can develop statistical inference procedures that are based on the normal distribution, even if we are sampling from a population that is not normal, provided that we have a large sample size. So we all know that a sample comes from the population. So even if the population is not normal, by getting an ample amount of your sample, then it can make the distribution normal. Okay, so to continue, we can use the Z conversion formula or the standard score formula, which is given by Z equals X minus the population mean divided by the standard deviation, the population standard deviation, over the square root of n. You have encountered already that formula. Okay, so as for our first example, suppose that the average of the people living in a barangay is 434 with a standard deviation of 4. If 100 residents of a certain barangay decided to take a summer outing after COVID-19 pandemic and enhanced community quarantine has been lifted for bonding and relaxation, what is the probability that the average age of these residents is less than 35? Okay? So what's the first thing that we have to do in order for us to solve this problem? Okay? First step, we need to write all the given. Okay? So for step 1, what are given? Okay, so we have the MU or the population mean, which is equal to 34, right? And then what else? The population SD, which is equal to 4. And then the sample mean, which is equal to 35. And the sample size is 100. So based from the given, we can now compute the z-score. Okay? So remember the formula, z-score equals the x. So what is our x? Or mean, sample mean minus the population mean. So that will be 35 minus 34. Okay, let's try to substitute based on the formula divided by the SD, population SD over the square root of your n, which is 100. Okay? So I have no math symbols for this. So basically, we will have 1 over, okay, so the square root of 100 is 10. So 4 divided by 10. So 4 divided by 10 is 2 over 5 or 0.4. So if you have that one, we have 1, which is the difference between 35 and 34. That's why we have 1 over our denominator, which is the quotient of 4 over 10. So that's why we have square root of 0.4. Therefore, dividing 1 and the 0.4, therefore, the z value is equal to 2.5. Okay? So that's the second step. And answering this question, what is the probability? So meaning, we need to find the probability of z, which is, where's that symbol? Okay, so I'll write na lang the symbol ha. Okay. Okay, z is less than, okay, text again tayo. Less than 2.5. Okay, so we need to look for the value of this 2.5 in our z table. And looking at the table for the value of the probability, okay, remember that one, if we will try to draw our, okay, normal curve. Okay, so sorry for that So the 2.5, assume that this is the 2.5. The z-score, which is 2.5, and that finding the probability, which is less than 2.5, it requires this region. So by looking at the table, z equals 2.5 is actually equivalent to 0.002. Approximately, Sa table po yun makikita, ha? Okay, sa table, na z equals 2.5, that is equal to 0. Less than, right? Ay, hindi. Whatever. That is 0.9938. So you can use your table. So therefore, finding its probability, it's the same since it requires this region, 0.9938. Okay? And or it can also be equal to 99.38%. So answering the question, what is the probability that the average age of this residence is less than 35, then it is equal to 99.38%. Okay? Okay, so let's proceed with the next module. The next module is about solving problems involving sampling distribution of the sample mean. And here are the objectives. Okay, so we only have 2 objectives. Okay, so basically, when we say sampling distribution of the sample mean, it is the frequency distribution. So you know how to set up a frequency distribution or the table, okay, of the sample mean computed from all possible random samples of a specific size n taken from a population. The probability distribution of the sample mean is also called the sampling distribution of the sample mean, and that the standard distribution of the sampling distribution of the sample mean is also known as the standard error of the mean. So please take note of that word, standard error of the mean. Okay, so here are the steps in solving problems involving sampling distribution of the sample mean. So first, you need to identify the given information. Just like what we did in solving the problem under the first module that we tried to identify first what are given in the problem. And then second, you need to identify what is being asked in the problem. Then after you have identified what is being asked, it's the time for you to look for the formula, okay? And then lastly, we need to compute the probability. Okay, so I have here an activity which is entitled probable time. So the mean time it takes a group of senior high students to complete a certain examination is 50.6 minutes. The standard deviation is 6 minutes. Assume that the variable is normally distributed. Okay, so to answer the different questions posted below, that for number 1, what is the probability that a randomly selected senior high school student will complete the examination? So in less than 48 minutes, as what is stated in the steps, you need to identify what are given in the problem. So what are those given in the problem? Okay, so first we have the population mean. Okay, which is, okay, meant tuloy na isulat, equal to 50.6. The population SD equals 6. And, okay, so what is this 48 minutes? The sample mean equals 48. So to answer number 1, okay, after identifying, we can now substitute all this given from the formula. Okay. Sorry, the formula is Z equals sample mean, right, minus population mean divided by SD only pala. Sorry for that. Okay, so this is the formula, okay, for the Z score. So substituting all the given, then we will be able to find that the Z score is negative 0.43. Okay, so if you know already your Z value, you need to find its critical value or the table value. And this negative 0.43 corresponds to a value of 0.3336, or that is equal to 33.36%. So that's the probability that, okay, wait lang po, a senior high school student will complete the examination in less than 48 minutes. Okay, so you can do the same for questions number 2, number 3, and number 4. Okay, so I will leave to you the solution for questions 2, 3, and 4. Okay, so that we can proceed with the next slide. Okay, so your first learning task for this week is entitled My Favorite Breed. So with the way we have computed, okay, so it's very important that you know how to use symbols for less than, at least, between, okay? And then afterwards, for describing this one, actually this is under formulating conclusion, okay? So that's your learning task number 3. For your learning task number 4, okay, so you need to supply what is missing on the blanks, okay? So those are the 2 learning tasks for week. Okay, so we're done with week number 7. So as we proceed with week 8, so the first module is all about illustrating t-distribution. So you have encountered what a z-score is, and this time we'll have this t-distribution. Okay, so we will learn the different properties, and then we will try to differentiate t-test from z-test. Okay, so this first activity is that you need to decide whether to z or not to z. Okay. So basically daw po, if is the sample size less than 30, okay? So you need to consider the number in your sample size. If it is a yes, then it is not to Z. If it is a no, it is to Z. Okay? So later, we will have explanation on that. Second one, if there is a given population standard deviation, is it a Z or not to Z? If there is a population standard deviation, then it is to Z. But if there is no population standard deviation given or just the sample standard deviation, it is not to Z. Okay? Third, okay, you need to point out the difference between students T distribution and Z distribution. So as is given here, we will use the T distribution if the probability distribution used an estimate population parameters when the sample size is small. Meaning if the sample size is less than 30, then you need to use the T distribution. Or if in case the population variance is unknown, then T distribution must be used. So this T distribution was first developed by William Selly Gosset in 1908. And it has a formula of T equals mean, sample mean minus the population mean divided by the population standard deviation over the square root of n. Okay, and then you need to find the degrees of freedom, which has a formula of n minus 1. Okay, and of course, if we have a Z table, we also have a T table. Okay, and then considering the T distribution, it looks like this one. Okay, so looking at the curve with a color red, if the degrees of freedom is equal to 3 or less, then you have this bell shape. If the degrees of freedom is 5, then you have the green bell shape. If it is 20, then you have the next, the violet, and then the blue for degrees of freedom of 30 and more. So what are the properties of T distribution? Okay, so it is symmetrical about the zero. That means if you draw a line segment from the peak of the curve down to the zero mark on the horizontal axis, the curve is divided into two equal parts. So as we have discussed as one of the properties of the normal distribution, whatever is reflected on the right, it's also on the left side. Okay, that's why it's symmetrical. Okay, so this is our illustration for that. Second property, the T distribution is bell-shaped like the normal distribution. So no question about that. Okay? Yan. So look at this one. But then looking at the tails, it's heavier, meaning it's far away from the horizontal axis. It's quite far from the horizontal axis, but then again, it's asymptotic with the horizontal axis. Third property is that the mean, the median, and the mode of the T distribution are all equal to 0. And that the variance is always greater than 1. It is equal to V over V minus 2, where V is the number of degrees of freedom. Yan. So we have this variance, okay, considering the number of degrees of freedom. And then next we have, okay, so as the degrees of freedom increases, the T distribution curve looks more and more like the normal distribution. So look at this one, okay. And that, of course, the area of the curve is always equal to 100%. Okay, and that the T distribution varies with the sample size. It is always greater than 1. Okay. Next module, identifying percentiles using the T distribution. Okay. So we have the activity 50 Shades of Gray. Yan. So we will try to find the area of the shaded part. Okay, so if this is 75%, of course, we all know that to subtract 75% from 100, we will get the 25%. So that is the shaded region. So with number 2, of course, it's 20%. So this is very elementary, ano? Yan. Okay, so given 85, then that will be 15. Given 90, it's 10%. Given 95 for the two tails, then you have to divide the 5%. Thus, we have 2.5 on each tail of the curve. Okay, so next we have the t-table. Okay, so in finding the areas and percentiles for a t-distribution, you need to familiarize yourself with the t-table. So you are going to use a table that is different from the z-table because we will be considering the degrees of freedom. Okay, so how do we look for that? So in the first column, as you can see, there is the degrees of freedom. So we have the formula n minus 1. So let's say, for example, your sample size is 25. Therefore, the degrees of freedom will be equal to 24 since 25 minus 1 equals 24. So this is the 24 for the degrees of freedom. Okay? Okay? And then let's say, for example, the assigned level of significance is 0.05. So the value of your t at 0.05 is this one. Yeah. So you need to look for the intersection of your degrees of freedom and the level of significance used. Okay, so these are the level of significance. But then again, you need to consider whether it is a one-tailed test or a two-tailed test. Okay? So if it is a two-tailed test, then you need to divide the level of significance. Say your level of significance is 0.05. So if it is a two-tailed, then you need to look for the 0.05 level of significance. Divide it by 2, then you will refer to 0.025, this column, okay, to find the area of that. So you can search actually this T table or T distribution in the internet. So actually everything naman can be Googled. Yan. So those are the T values, these are the degrees of freedom, and then the area in the right tail. Okay? Yan. So let's say, for example, find the 95th percentile of a t-distribution with degrees of freedom 6. Okay? So you know that this is 0.05. So meaning we need to look for the column of 0.05, 0.05, and 6 minus 1 is 5. Therefore, the t-value is 2.y19. Okay. So this is incorrect, ha? We need to look for degrees of freedom, yeah. It's already given pala, not the sample size. It's direct that the degrees of freedom is 6. So intersection of 6, this one, the degrees of freedom, which is 6, and 0.05%, this one. Yan. So it's 1.943. So it's easy naman to look for the table, right? Okay, let's have the next slide. Okay, what is the area to the right? Yan, area to the right of 2.4. So this is the area needed with degrees of freedom, which is 7. So 7, and then, so if it is 2.4, look for 7, 2.4. Where is that value, which is 2.4? So that is between 0.025 and 0.02, right? Okay, so in this case, we'll just put between 0.025 and 0.02. Yan. Okay, but actually there is an app. If you will search in the Google, you can have an exact value for this. Okay? But if you don't have, just refer to the table, and wherever the 2.4 lies, that will be the area needed. Okay? Okay, next module, identifying the length of the confidence interval. So these are the objectives. Okay, so what's the difference between confidence level and confidence interval? So when we say confidence level, it is the probability that the interval estimate contains a parameter. Okay, when we say parameter coming from the population, it describes what percentage of intervals from many different samples contains the unknown population parameter. So this is already the table for the confidence level. So you don't need to look for the value, ano. So it all depends on the confidence interval used. So if it is 99%, then we have this value of Z, and then for 98, and so on and so forth. Okay? So next we have, yeah, the confidence interval or interval estimate. So you need to know your lower limit and your upper limit. And your lower limit and upper limit has a formula of mean minus yan, E, or the marginal error. This is actually the mean, ano po, whatever is the mean. I have no symbol for that. Yan. Okay, and to find the margin of error, we have this formula. Yan. So this one can be look for at the table. Ano po? So you can look for the value of this from the table. Okay, so let's say, for example, this problem. A random sample of 46 scores from the examination of Hume's learners is taken, and it gives a sample mean of 78 with the interval scores between 77.18 and 78.82 having a 90% level of confidence. So which of the following is the mean in the given statement? So which do you think is the mean? Okay, so you're correct. That the mean of the given is the 78. Where am I yan? This one, the sample mean, the 78. So what is the upper limit? So the upper limit is the 78.82, this one. And the lower limit is 77.18. Okay, so what is the margin of error? So you can compute the margin of error by simply subtracting 78 and the margin of error. What is our margin of error nga? Okay, we need to find first the margin of error by simply subtracting the lower limit and the upper and lower limit. So UL minus LL equals, so the margin of error is 0.82. So therefore, okay, so the margin of error here is 0.82 And then answering letter D, what is the confidence interval? Okay, so the confidence interval is that it is between 77.18 and 78.82. Or in symbol, you can have the population mean is greater than 77.18 but less than 78.82. Okay? And then for letter E, what is the confidence level? The confidence level is the 90% or the level of significance. So how are we going to conclude? So we are 90% confident that the mean score lies between 77.18 and 78.82. Okay. Last, how do we compute for the length of the confidence interval? So those are the objectives. And this is our formula. Again, for the margin of error, we have the formula. E equals Z alpha over 2 times the population SD divided by the square root of n. So to find the length of the confidence interval, we have this formula. So L stands for the length, which is equal to upper limit minus the lower limit. Or if in case the lower limit and the upper limit are not given, then you can use the formula to find the length of the confidence interval twice your margin of error. Okay? Okay, let's have this example. The population of... Okay, wait lang. I can't read this. I can't read the problem. Okay, so I'll try to show the solution. Okay, there's no solution. Okay, wait. Okay, there you are. Yan. So we have the example. Isabel owns a shoe store. She used 160 pairs of shoes as her samples for the different designs. The population standard deviation of the price of the shoes is 75 pesos. Suppose that Isabel wants a 95% level of confidence to determine the mean price of all her shoes she is selling. Compute for the margin of error for her is estimate. Okay? So computing the margin of error, again, looking back at our formula, we have the Z alpha over 2 divided by the population standard deviation divided by the square root of n. Okay, so looking at the table at 95% level of significance, the Z value natin, or the margin of error, the Z alpha over 2 rather, okay, is this one at 95%. Is 1.96. So if you have your calculator with you, then we can compute for the margin of error. Okay, sorry for the writing, is equal to 1.96 times the quantity, population SD. What's our population SD from the problem? The population SD is 75. Okay, this one. The 75 pesos divided by the square root of our n. Our n is 160. So square root of 160. Okay, so if you'll compute that, then the margin of error is approximately equal to 11.62. Okay, so that is how we compute for the margin of error. Okay, let's proceed with the next slide. Okay, next module, computing the appropriate sample size using the length of the interval. Okay, so these are the objectives. Okay, so why is it very important for us to make use of the sampling size? So it is important to know your sampling size to make an accurate and valid estimate. Okay, so getting your sample size, it's not that whatever you want, the number whatever you want in your sample, that will already be your sample. So we have a formula for us to get the sample size. So n is equal to Z alpha over 2, so from the table, times the population SD divided by the margin of error, then you need to square that. Okay, so whatever is the value of this, then this will be your sample size. Okay, so still we need to consider this table for the confidence level. Okay, so let's say for example, a company president wishes to estimate the average number of hours his part-time employee per week. The standard deviation from previous study is 9.3 hours. How large a sample must be selected if he wants to be 99% confident of finding whether the true means differs the samples by 4 hours. Okay, so how are we going to solve for that? So first, we need to write all the given. So what are given in the problem? Sample mean equals 4 hours. Okay, the population SD equals 9.3. What else? To be 99%. Okay, so we'll try to get the value of this 99% from the table. Let me see if I have. Ayan. So these are the given. Okay, so the alpha is 2.58. The margin of error is 4. Okay, so this is not the margin of error. Confidence. Sample mean, ha? This is the sample mean. Okay, so solving that one, then the sample size is 36. Okay, so sometimes there are factors that may affect your sample size determination. So what are those factors that can affect your sample size determination? So first is your margin of error. Okay, so since no sample will be perfect, you need to decide how much error to allow. So if you are very confident that your study is almost perfect, then you can use your level of significance, which is 99%. But if you have some doubts, then you can use the 95%. So it depends on you, okay? But remember that the less error you're willing to accept, the bigger the sample size needs to be, okay? So that's the first consideration. The second consideration is the population standard deviation, okay? And then the third one is the confidence level. So for the confidence level, it determines how certain you want to be that the parameter falls within your confidence interval. So most common confidence intervals are the 90%, 95%, or 99%. So same with the margin of error, that the less error you're willing to accept, so meaning you are confident enough, the bigger the sample size needs to be. But when it comes to confidence level, the more confident you want to be, the bigger the sample size needs to be. Okay? So those are the three factors that may affect your sample size. So for the third learning task that you have to accomplish for week 7 to 8 is this one, entitled Solve Me. Yeah. And then for the last one, we have this one, last module for week 8. So, and we are done. Okay. So we have that one, the problem. So considering this problem, so our confidence level is 95%. So from the table, that is equal to 1.96. Okay. So margin of error is 3 because of this 3 minutes, and that the population standard deviation is 12 minutes. So solving for that, for the sample size, we have 62. So approximately equal to 62. And for our margin of error, which is less than or equal to 2, then we have this sample size. Okay, why do we need to get this? Because as stated in the question, how many people do you need to observe so that the desired margin of error will not be more than 3 minutes with a confidence level of 95%? So if you are, or if your margin of error is 3, then you have this sample size. But since it is more than, you need to get the value when it is less than 3. So less than 3, so assume that that is 2. This is our sample size. Okay po? So as you can see, as the margin of error decreases, so given this one, okay, the sample size gets bigger. Okay? But if the margin of error gets bigger, then your sample size gets smaller. Yan. So this is an illustration. Obviously, if you have your margin of error 3, okay, given the smaller confidence level, okay, then look at the sample size. So as the sample size gets smaller, so as your level of confidence. Yan. So I have mentioned already this one. Your learning task number 4. You need to complete lang po, supply the missing on the blank. Okay, so that's all for our last week. Thank you, everyone.